Hello and welcome back. In the stream that I sent last week and the stream that I did yesterday, um, could not get the recording. I actually forgot to set the setting to record it and publish it automatically. So we could not get the recording of the stream to be posted onto the video section. So I will be repeating what we discussed yesterday and take it forward so that I can have this recording available and post it into the channel. So hello again. What we would like to do in the next few days is we will be building REST API microservices, but instead of just building it in one specific language or technology stack, we will be building the same API microservice in 5 different stacks. Why should we do that? First of all, the concepts and the technology behind the REST API itself and how it interacts and allow you to integrate different systems, those concepts do translate really well irrespective of which language do you choose. So because in all essence the concepts remain the same, how we implement it is based on the programming language, the framework that you choose. So the concepts do translate really well into any programming language and any technology stack. And there are only few things that you need to learn about that specific programming language and stack. And the biggest benefit is now you could expand your opportunities for a career or even growth in your career by being able to build REST API microservices in most predominantly used stacks. That means you should be able to get a job or advance your career in any organization irrespective of the technology stack. And you may have already known, if you're already working in the industry, most of the enterprises still use Java with Spring Boot or a framework that is similar to Spring Boot, and C# with ASP.NET if that enterprise or the large organization is a Microsoft shop. And all the new startups and small and medium businesses will be using much modern lightweight cores like JavaScript or Nodejs, Python with Fast API or similar framework, and some advanced work, particularly where the jobs or the APIs will have to process data intensive tasks. You may see with Golang as well. And particularly in the CNCF world, the cloud native world, but around Kubernetes, for instance, you will see tons of new tools and new frameworks that are all built with Golang. Out of 6 out of 10, if I recall correctly, the top frameworks in the CNCF Foundation projects list, they're all built with Golang, for instance. And few other tools and few other frameworks are also built with Rust. So you will see that the newer modern organizations that are relying or trying to build these services for Kubernetes environments, you will see a good mix of these new technologies, whereas some of the existing enterprises where they must have invested tons of money over a period of time to build these great business functionality services, starting with the web services with SOAP, if anybody recall, all the way to the today's modern stack. You will see still using Java, Spring Boot, or Scala, frameworks like Akka, for example, and C# with ASP.NET Core, or C# with plain old traditional ASP.NET. So this is going to give you that opportunity to learn how each organization or each team that implements these REST API microservices and expand your career in a nutshell. So that's the biggest advantage. But from the organization point of view, as well as a team point of view, now you can actually pick the stack that's right for the job. Data intensive task, maybe you could pick Python, because Python has a great ecosystem of algorithms, data science, and analytics frameworks and libraries available. You may want to do some video compression, video processing, and other intensive, memory intensive tasks, as well as processing intensive tasks. You will be better off picking Golang, for instance. Same with Nodejs. Nodejs is built for building API services with its support for JSON in a native way, for instance. And they're also very, very simple, lightweight processes too. So you may pick JavaScript for REST API services, Golang, similarly Python for data or data intensive data science projects. If you want to expose your ML services, data science services, for example, you may pick Python. So this gives you that ability to pick and choose the right stack based on the job. And as a professional, as somebody that is learning to build these microservices, now you could build these services in anywhere. And we also will look at various deployment options, starting from AWS Lambda, which is probably the most lightweight and serverless option, to container-based options. The traditional container-based option is, of course, ECS, but you could also train yourself to deploy your applications into Kubernetes. And Kubernetes ecosystem will give you tons of advantages to work or make yourself capable of entering any organization, any team that is on Kubernetes of any kind of flavor, whether they're running native Kubernetes or they're running these managed services like EKS in Amazon, or Azure Kubernetes service like AKS, or GCP, the Google Cloud as well. So you can see, by learning to build your API microservices and learn a few more aspects on how you can deploy your microservice to Kubernetes environment. And there are a few semantics that you need to learn about. These are in addition to the basic concepts of REST API. But once you learn these semantics on how your API service can be deployed to Kubernetes environment, suddenly you are opening up yourself to variety of organizations to be able to find that opportunity as a professional to grow. So that is a background. The two-edged motivation for this. First one is, of course, to help you to build these microservices and deploy anywhere, pretty much serverless all the way to the Kubernetes environments. And you will learn that a good chunk of the knowledge that you have, or you're going to learn to build these API microservices, can be translated very easily, no matter which stack and which programming language you choose. So you could broaden your expertise in variety of technology stacks. That opens up more opportunities for a job, or more opportunities to grow in your career as well. And other one is, it will help you to pick the right technology for the right job, so you can build more efficient, more scalable services, no matter what kind of workload you need to support. So initial list of stacks, I'm going to look at JavaScript, of course, and instead of using the traditional Express, I'm going to use Fastify instead. And I'm going to use Python with Fast API and JavaScript with Spring Boot. Go with Gin and C# with ASP.NET Core. And once we finish these, I would like to bring in Rust as well with Actix. I would like to gauge some interest before I get to the Rust, because Rust is I would say, kind of relatively newer programming language, and not many people have exposure to Rust as a programming language. So I would keep it at the last. Once everything else is done, those 5 stacks are done, I will jump into 6. And if you or any of your friends or colleagues are interested in learning how to build API microservices and be able to deploy to any environment, please let them know. Please share this information about this stream and let them take advantage of this course. And I would like to make sure that I can reach at least 200 people in the next few days to be able to help them grow in their career or advance their career and broaden their opportunities to be able to build these microservices in any programming language they want. Okay, now I would like to list out some of the service features, the API features that we will be building. And these are specific to each stack that you will build. So you will be building these services differently in each stack. There are some idiomatic expressions or idiomatic ways of doing stuff in each programming language or each stack. So we will follow those idiomatic expressions so that you will feel like you're at home, which no matter which technology stack you'll be working on. So we are not learning about the common denominator across all these stacks. Instead, we will take the best of the frameworks and best of the idiomatic ways of doing stuff in each programming language. So we are learning the best in each stack, but there are still a good chunk of the knowledge is still transferable across the stacks. So we will be setting up our framework to generate API documentation automatically. There are some limitations to what can be generated and how we can validate it, but we will do our best to get our documentation 100% automatically generated and being validated. We'll also learn about how to implement API versioning, and this is very important as aspect as well. If you're learning to build any kind of non-trivial API application, versioning is very important because you will keep modifying your API pretty iteratively. We will also talk about API security in the sense of authentication and authorization. We will be relying on OAuth 2 for a major chunk of validating the authentication authorization for our API microservices. And based on the interest, I could also cover other aspects too. And how we implement this middleware to authenticate our authorization for each API request is specifically dependent on the framework we are using and how the middleware is wired up in each of these frameworks. So we'll talk about that in the context of each stack. That's why everything that you see here as API service features, these are dependent on the technology stack that we are working at that moment. So you will see those dependent aspects and how to connect to the database. And we will look at connecting to a database like an RDBMS database, probably Postgres, and a NoSQL like DynamoDB or Cassandra. One of those 3 examples we could use. And how you do logging in API is also dependent on the stack that you will be looking at. So that is another aspect that you will be working on as far as the stack is concerned. Same thing with metrics and KPIs. How you collect, how you report those metrics is also important, and is also dependent on the framework you are using. Health check, of course, it's the most trivial aspect of any API service. And unit testing, this is the most important part as you build your API microservices based on the framework you choose, based on the programming language you choose. You will have to choose the right unit testing framework as well, and we will do that in the context of each framework as well. For example, Nodejs, you may pick Jest, and if you go to Java Spring Boot, maybe you will use JUnit, for instance. Data validation is also different in each framework. We will look at that, as well as error handling and request tracing. These two aspects are also different based on the context. However, there are some common features which are typically outside of the API service. So for these, we don't need to depend on the technology stack. We could pick the best of the tools available in the ecosystem and build these services outside any of the technology stack. That way, you can use the same tooling and framework that you build against any API, whether you build your API in Java, build your API in .NET or C#, Golang or Node. This is external, so we could do performance testing outside the bound, so you prepare these test scripts once, and you can run them against any of the stacks that you're going to build. Same thing with the contract testing or integration testing. This will be an external test to your API microservice. That means you can actually build this externally without depending on a specific stack, and the same test can be run against each of those APIs too. And there are some features that are required for any API microservice, but we're not going to build these into the API microservice. Instead, we will rely on other infrastructure to be able to provide these services. For example, API gateway, a load balancing, rate limiting, caching, request tracing, and a firewall, for instance. And I could explain you in the context of AWS and then also in Kubernetes, and you should be able to follow along if you want to build and deploy into Azure or Google Cloud, for instance, seamlessly, and in any other cloud as well. Most importantly, everything that you do in the context of Kubernetes is you can easily translate that into any Kubernetes environment, whether it is native or it is managed by the public cloud. And there are a few prerequisites, and I will guide you as well if you are new or if you are already familiar. This is great. You can get started quickly. Otherwise, I will share some resources that will get you up to speed as well. We definitely want to see if you have some basic knowledge of programming in any language. Doesn't matter what language it is, but it's definitely easier if you have some understanding about one programming language. And if you are good at one programming language, you can easily learn other programming languages because there are so many things you can easily translate. A good chunk of these concepts are common across all the programming languages. Your problem solving logic, algorithms, data structures are very similar. However, you will be learning a little bit more about syntax, plus there are lots of features these languages do provide. For example, how do you do asynchronous programming? How do you do functional programming? So these aspects could be different in each programming language, and you will learn them on the way. So some of those concepts include the basic understanding about the REST APIs as well as database. And if you're new, we can definitely help you so that you can learn a little bit more before you get started with this stream and the program. It is good if you already know what REST API is, but in one of the discussions, I'm going to cover that aspect as well, and we will trace the background on how a simple API request that you send either from a client like Postman or command line or from an application, how does it route it back to your service and gets executed and sends the results back. We will look at that life cycle. And it will also be very helpful if you have some basic knowledge of the database. If you're not familiar with any of these, you can quickly hit YouTube and just type REST APIs or database and follow along any good video for an hour or two. You should be able to get some high-level understanding on these concepts, and that is good enough. Don't wait until you become an expert in any of these. You just need enough knowledge to be able to get started, and you learn a lot once you start using those concepts and start implementing stuff. and some other concepts that you would like to go through as part of this discussion, but you're free to go out and learn on your own as well. It will help you to accelerate the implementation of these services. Basic understanding on what microservices are and some of the benefits of microservices. For instance, OAuth 2, this is the authorization protocol, and a counterpart to this is the OIDC, which looks at the authentication side, and OAuth 2 looks at the authorization part. You need to know both, even though in the context of API microservices, we will be predominantly looking at OAuth 2 for the authorization angle. But if you would like to become a full stack developer, you better know both aspects of the security, authentication as well as authorization. Open API specification. If you're aware of Swagger, you already know most of what Open API specification really means. Before, it used to be just called Swagger, and the newer version is called the Open API because it's no longer a proprietary format. It's kind of a common format, and it's open and managed through an open ecosystem. And now the version typically referred to as 3.x is Open API. And you'll also learn a little bit about serverless, the essential concepts of serverless, and we will also use containers and deploy our services to Kubernetes. So you'll learn more about the containerization as well and Kubernetes as an ecosystem. And of course, you need to learn about Docker, Postman as well. Postman is an API client. We could use it for manual testing or interactive testing or exploratory testing, but also you could run those tests that you're going to build in an automated fashion. And AWS Cloud is what I will be spending most of my time. Use AWS Cloud for serverless, ECS, and EKS, which is a managed Kubernetes environment. But the concepts are very similar. And towards the end, I will also set up a Kubernetes on your local machine with using Minikube. That way, you're ready to deploy your services no matter which Kubernetes environment that you will run into. So there's a very high level idea on what we will be working on as part of this series of streams that I will be sharing. And again, as I said, if any of your friends or colleagues that will be interested or that may get benefit from this program to learn more about building API microservices, or either they're learning or they're already working in an organization in one of these technology stacks, but now they want to expand into other technology stacks, please let them know. Please share this stream information with them, and I appreciate a lot. My goal is to at least help 100 more people to be able to build these APIs in any technology stack of their choice, or Kubernetes environments or microservice environment allow us to have these API services in different languages coexist in the same environment. So if you have 10 microservices, for example, each of those microservices can be built using a different language and different technology stack, taking the best for the job that you're looking to, or the problem you're looking to solve. So it's the best of both worlds in those cases. You can pick the best tool for the job in the context, and able to build a successfully scalable and modern API microservice. So that's a very high level, and I'm organizing the folder structure as well in this way. So as I said, we did this stream yesterday, but we could not get the recording done. That's why I'm redoing that section again. So we created this as a folder structure. I'm going to push this code up to GitHub, and I'll share the GitHub repo so you can take a look at it and continue to follow along. We have a source folder. This is where our API microservices will live. For example, I created a sample that's for Nodejs stack. using Pastify, and so we will have one folder for each technology stacks. Currently we have Node.js, and once we finish Node.js and go to the next stack, we'll create corresponding stacks as well. And everything else is what we considered as common, that we will be doing performance testing. For example, we could do the performance testing irrespective of technology stack, because it's kind of considered as an outside stack. So that's why these are kept outside. And I'm going to build only one set of integration tests, one set of performance tests, one set of security tests, and those can be run against any of the stacks that we are going to build. Whether we use Node.js, Python, Golang, doesn't matter. We should be able to run those against it. So currently I just put a placeholders with README files, and we will be filling that in as we plan and discuss. Our next step is to identify what API service that we would like to build. We'll take some real world example that could be useful in the real world, that you could share it outside. But I would encourage you to pick and choose something that you would like to solve. I want you to pick a problem that you would like to solve. So think about in your ecosystem, in your daily interactions, either in an organization with your friends or colleagues, or generally in your community. Is there a problem that you would like to solve by building an API microservice? It will be great if you pick your own problem, learn the example here as I show it, and you go and build your own API. That is the best way to learn anything, because not only you are trying to apply every single aspect of what you are learning, but you're also thinking a lot more in the context of the problem domain. That's the most important part. And I request, please do not just watch the video and think you understood and you're good to go and think that you already mastered the concepts. Unless you actually build your own code and execute that code and test your code, you're not learning anything. You may hear about stuff if you just watch it. And I also strongly encourage not to just clone the code that I'm going to share and run it and think, oh yeah, this is all good, it's working, I know what it is, and I just ran the code, so that means I already know exactly how everything is working. That's another reason why I'm asking you to choose a problem that you would like to solve for yourself as you are learning. This is the best way to learn anything and master anything that you're learning. Please do not just watch or just run the code that is shared by somebody else. You have to type that in. You have to be thinking about what you're solving, why you are solving, how you are solving. You can learn the concepts, but use those concepts and apply it in the context of the problem that you are solving. That's the best way to learn any technology or any problem solving methodology, and this is not an exception. Okay, so before we go to build a sample Node.js stack, and we are going to just build a health check API for today, I would like to point out to the 2022 state of the API report. This report has been published by Postman, which is the API client that we are going to use. And you're not limited to using Postman, you could use whatever you want, and there are lots of other clients. One of the most common one that you see in the enterprises is Insomnia. Doesn't matter which tool you want to use, there are I would say about 90% of them are exactly same. There are differences in how you interact in terms of performance, how you organize it, but they're pretty close to each other. If you learn one tool, you should be able to master the other tool pretty quickly as well. So this is Postman, and they did a survey, and there are about 37,000 developers and API professionals responded to the survey. So it's a good chunk of information on how people are thinking about APIs in the ecosystem. Take a look at it, probably just skim through it, spend maybe 10-15 minutes to go through it and then understand the ecosystem. There is a lot of good news in that. So it is worth spending that extra time to invest yourself to learn more about APIs, how they work, what technologies, what is API first strategy mean, for instance, and all other aspects as well. But I would like you to read for yourself and make that call. Based on my understanding, based on my experience, APIs are like the highways in the digital world. There is no service that I know of currently, either it is running on my iPhone or in your desktop or in an IoT device. Everything works on top of an API. There is no service that I know of that doesn't use APIs at the moment. So APIs are really integral, and they are like superhighways for the information age, and it's worth spending the time to build these services, and it'll help you to grow your career as well. But take a look at this, and there are interesting aspects from the survey, how they're, what is the growth look like for APIs in the global, international, who is working with APIs, what do they do if somebody is working on building APIs, what are some of the things they do in a day or week of a year, and what does API first strategy means in the context of their organizations currently, what are the tools, technologies, and what's the future look like in the words of people that responded to this survey. Like, what do they think? And short answer is, everybody is thinking that they're going to double down on their investments into building more APIs, and there is some concerns around the proliferation of microservices and how to manage them, because the microservices means you're going to build small and independent units of services which provide an independent business functionality that can be built, managed, and deployed independently by a small team. That means you will see tens of services in a small application to hundreds to thousands of these services in a bigger organization, which means you should need some tooling as well as some basic processes and guidelines to be able to manage this, because you no longer have one repository or 10 repositories. Now you have thousands of repositories. For instance, if you use one repository for GitHub, one repository for one service, for instance, leave alone the integration and communication between these APIs. So it's a good report. Take it with a pinch of salt when it comes to the tooling, because this audience that responded to the survey are predominantly Postman users. That's how they reached out to these professionals in the first place. So accept that, take it with a pinch of salt in the tooling section, because you will see Postman is the most preferred tool. That's not necessarily true. You will run into teams and organizations that never even heard of or use Postman. They have other tools, for example, but Postman is probably by far the most common tool that most people use. So, but take it with a pinch of salt in that section, but everything else is still good report to read through. So take a look at this, and I will be using Postman as part of our discussion and our testing. So I created a collection called Polyglot REST API Services, and I set up a health check as part of the stream yesterday. So I would like to quickly walk through that node service right now, how to set up the fast API framework, and we will simply build the health check today, and in the next stream next Saturday, I'll try to get more streams in between, but if not, I will guarantee that we will meet again on Saturday. On Saturday, we will expand that and actually build more routes. And by the time, I will also find out one problem that we would like to solve, that what API service we want to build. And this will also give you enough time so that you can build, or you can pick a problem that you would like to solve as well. Okay, I will take a 2-minute break, and we will come back and then set up our first Nodejs based technology stack with Fastify, and we'll build a health check API to start with. I will be right back. If you have any questions, let me know on the chat. And again, if any of you, your friends, anybody in your community or anybody in your colleagues would get benefit by learning about API microservices, all the way from thinking about microservices to building them, testing them, and deploying them anywhere, please share this stream information with them, and appreciate sharing them, because my goal is to at least teach 100 more people to learn about and be able to build these microservices. I'll be right back in 2 minutes and we'll build a Node.js stack. Thank you. Okay, we're back. And first thing I will do is show how to set up your Node.js project. Again, I want to share that I did this stream yesterday, but forgot to set it up to record and publish. So I'm actually repeating the stream. That's why the code is already there. But in all the future streams, I will be building these API services live so that you can follow along as well much more easily and ask questions as you do it as well. And again, as I requested earlier, please do this. Follow along and code it and build API service on your own. Watching and running somebody else's code doesn't help you at all. You may hear about it, or you may understand a little bit about it, but you will never be able to apply it in the context of your job or your own project. So please open this up on a second window and then follow along and actually do it. That is the best way to learn. So please do actual hands-on coding instead of just watching it. I'm not here to show what I know, and I'm pretty sure you're not here to see what I am capable of. As much as you learn, I'm also learning and sharing what I'm learning, and we can all learn together only if you also follow along and do it, and then share your experiences, your learnings as well. So please do hands-on, just don't watch it. So first thing is, I will share this repository and structure, but if you want to get started today, create a folder and then create a folder called src if you want to use the same structure, but feel free to use whatever structure makes sense to you. and under source, I'm going to create first folder for the Node.js stack, because we will be building this service in 5 different stacks. So we will have one folder, subfolder for each stack. So first one being Node.js. And the way you set up your Node.js project is do npm init, for example, and just follow the prompts, give the project name and the description, and just enter, follow the prompts to enter the rest of the information. And once that is complete, it's going to create a package.json file for you with the name and description that you have shared. And if you don't need to answer all the prompts, just let it take the default and finish it up. We will come back and set it up anyways. And the next one I would like to do is I'm going to use a framework called Fastify, which is a much better framework than the traditional Express, which is much faster, is one of the best frameworks in the Node.js ecosystem currently for building REST API services. So we are going to use Fastify. So go ahead and do npm install Fastify, and that will set up Fastify for your project. So just two important steps. You do npm init, set up your project, which will create the package.json. And once you are in this folder, go ahead and do npm install, which is npm and short for I for install, npm I Fastify, and this should set up Fastify as a dependency for your project. This is all you need to get going. And the next thing is, my preference is to call it as app.js, but you can also call it as server.js, service.js, main.js. You're free to use whatever convention you would like to use. I'm going to call it as app.js. And in the app.js, the first thing that I do is use the require semantics to get a reference to the Fastify framework itself. And as I said, we are going to create only one route for today, which is the health check route. And you can see I'm actually using this health check route at the root level itself. So if your API service is api.xyz.com, then / and this will be the health check. And in the next stream, next Saturday, we will learn about how to set up these route paths, what is the best way to set up, because we also want to support versioning, which means we want to include the version number into the path too, but we will talk about it later. So for now, we will be hosting our health check at the root level of the path itself. And I will always go with async, even though you could do a common callback convention and not to use asynchronous format, asynchronous semantics, but I will always go with async, and I will talk about all kinds of advantages that comes as well with async model. Each request, each handler receive request and reply, and we are just going to return the value, and this is semantics are okay. There are other semantics as well where you can directly call reply to send the response back. Since we are using async, I will be just returning the value at any time, and by default the value that is returned is expected to be in JSON format, so we don't need to specify anything extra about what type of content we are sending back. This framework assumption is that all incoming data in the body will be in JSON format, all outgoing data we are going to respond with will be JSON format. And then we will be starting our server. This will be a slightly different step as well based on where you deploy, how you deploy. But since we are going to run it currently on the local machine, so this is perfectly fine. And again, I'm using a async function that will just start your Fastify server and listen at port 3000, and then I'm going to start the server. So now we can go ahead and start your app.js. I'm not in the proper folder. So I just started it, and you can see now the server is listening at your local host and 3000. And if we go to your Postman now, and we also set up our Postman script that will call that API, and particularly we are calling the healthcheck API, and this is a GET request, and you can see in our code this is a GET request. And we will learn about various methods that are available in the next stream as well. Let us start with just one simple GET request to get the healthcheck. And now that server is running, I can go ahead and send the request, and I should get the response back. And if you look at the headers that are received in the response, you can see the content type is already set to application JSON to indicate that the response that is sent by the server is in the JSON format, so anybody should be able to process that as well. So that's a simple health check API that is set up into our server. And right now we are not doing any crazy stuff here. We're just returning status. Okay, this at least means that the plumbing that is required to set up a service is good, and we are able to start our server, and server is running now, and we are able to get the health check response back. So I'll pause here for a minute just to make sure that you get a chance to run this service as well. So ping me on the chat if you need any help, and please go ahead and npm init first, then npm install fastify. This is spelled as FAST, fast, and IFY, fastify, and then create a file called app.js, or you could also call it as server.js, index.js, main.js, or something of your preference. And all we are doing is getting a reference to the fastify module and setting up a get route. This is the most simplest health check route, and we are not doing anything fancy here. We're just returning status as okay. By virtue of returning an object, this is returned as a JSON object, and by default the framework assumes that you're returning a JSON object. And of course we are starting the server, and then setting up the start function, and we're calling the start function in the code itself. So when we go and deploy this, depending on where you are deploying, you may use a slightly different semantics here on starting the server. For instance, if we want to go and deploy this as into AWS Lambda, we don't need to actually start the server. We'll just export this application, and that should be good enough to handle. So this is just allow you to run it local, as well as if you will be deploying this as part of Docker container, you will still need the server to be running inside the Docker container, and we'll be doing a port mapping so that the traffic that is sent can be received by the service running within a Docker container. So we will learn about those semantics as we go through the rest of the program and understand what makes sense in what context. So I'll give you a couple of minutes to give it a try, and I'll be right back, and I'll be looking at the chat window to see if anybody have any questions. I'll take a couple of minutes break and come back. Okay. Anybody have any questions on setting up Fastify and wiring up our health check endpoint? Okay. We'll also share uh, this GitHub repo. I will be pushing this up to GitHub, and we'll post that GitHub repo as well in the chat window. And we will come back again on next Saturday, and I will try to share if I can do more streams in between. But if I could not manage to do anything this week, we will meet again every Saturday and Sunday for an hour and a half to 2 hours at the same time. And like I was asking everyone to think about a problem that you would like to solve. It could be your hobby project or your project for your community, or a open source project that you're working on where you're thinking about building an API service, or this could be a model project based on your work. If you're already working at an organization as either full stack developer or a microservices developer, for example, think about that, because thinking about any of these decisions in the context of a problem that you would like to solve is the best way to understand why certain way of doing stuff makes sense versus all the other alternatives available. So that will help you to judge and make a call on what is the best thing I could do or best way I can implement for this specific problem, for this specific context. Because there is no one single rule, one single architecture, or one single, I would say, best practice per se that work everywhere. You need to pick and choose the right tool for the job, right architecture, right strategy, and right way of implementing the API service. The more you learn, the more you practice, the more you do hands-on, the better you become to make those judgment calls and pick the right tool for the right job. And that is again essence of why we are trying to learn building these API microservices in variety of technology stacks. And we'll start with JavaScript and Node.js, and we'll be using Pacify as the framework. But and we will do the rest of the stacks as we move along. We will build similar same API contract, but similar API will build with Java with Spring Boot, Python using a framework called Fast API. We will build it with a Golang with a framework called Gin. We will build it using C# with ASP.NET Core. The reason I am using ASP.NET Core instead of the traditional ASP.NET is the ease of deploying this service into a container, so that we can deploy this service in any Kubernetes environment or any containerized environment. And once we finish these 5, we will go to Rust, and we will be using a framework called Actix. And by the time you finish these, probably it will take 4 to 6 weeks for us to be able to build it. By the time you finish these 6, I think you will see the essential concepts around API microservices, and how so much of what you're going to learn about API, the general concepts of APIs, can be translated so easily, irrespective of which programming language you're going to use or which framework you're going to use. Because you will see there are more things that are common across these versus different across these frameworks. Of course, each framework has its way of, I would say, typically referred to as idiosyncrasies or ways of doing stuff. Some of these frameworks have specific conventions on how they use it, how they think about these, for a good reason. Every framework has a reason why they do stuff in a certain way. But the more you understand it, the more you will appreciate why certain things should be done certain way, and pick and choose what works for you in the context of the program. And even though we will be focusing for the entire this exercise building REST APIs, somewhere in the middle of this program, we will also talk about GraphQL, why GraphQL makes a huge difference for certain organizations. GraphQL is not a good choice for everybody and every organization, every product, but we will talk about why GraphQL matters for certain contexts of API services that you are going to build. And another aspect of building these services is also to look at all kinds of vehicles, or I would say the ways the API can be consumed. GraphQL is one variation of it, and if you are in the industry for some time, you must have heard about SOAP and web services, for instance. They are kind of now pretty much like in the past tense. No longer anybody is going to build web services going forward. A good, I would say almost all organizations moved on to REST API, and some organizations, again, as I said, it's not ideal for every situation, but you will see many organizations also use GraphQL. For example, GitHub moved from REST API to the newer version is all supported in GraphQL, and you'll understand why they did the choice. And there is a lots of great blog posts written about why they thought it's a good approach for them to switch from REST API to GraphQL. As I said, it's not going to be is the choice for every organization, every product, and I will explain when it matters, when it doesn't matter, so you have that in your knowledge base. So we will look at GraphQL at some time. Also, we will be looking at WebSockets. WebSockets will be able to help you for real-time interactions, whereas REST is predominantly, or I would say not predominantly, exclusively, I would say, is a request response mechanism. And we will be relying on building these REST APIs as complete stateless APIs. It is still possible to maintain state to certain extent, or at least simulate maintaining a state to certain extent wherever you need to maintain that state. But we will be building REST APIs as completely stateless services, and WebSockets offer the real-time interaction, keeping those sessions alive, the context of the user or the application in that context alive as a session with a continuous stream of events being exchanged between the client and the service. And we'll talk about WebSocket as well, and we'll also do some exercises to build some of the business logic that we have and expose it as a WebSocket as well, a WebSocket API as well. Some of these semantics will be entirely different with respect to WebSockets, but we will discuss it once we go there. So even though predominantly we'll be focusing a lot on REST API, but we'll also learn about GraphQL and WebSockets as well. And if time permits, we'll also look at gRPC too, which is also predominantly used, particularly within the boundaries of an organization. So we'll talk about gRPC as well. So by the end of the end of this program across various streams, I hope to share everything that I know about the API ecosystem and at least help 100 of you to become proficient with everything related to API microservices, thinking about them, picking the right architecture, building them, deploying them into a variety of environments from serverless to Kubernetes environments, and actually operating them as well. So I hope this will be helpful. And if you have any questions, or if you have any specific requests on what you would like to discuss or what you would like me to discuss in these streams, please let me know. Drop a message in the chat. And I will also definitely appreciate if you could share, if anybody else in your ecosystem friends, colleagues, or somebody in your community could take benefit of this program, please let them know and let them follow along this channel as well. Thanks a lot and have a great night. And if you're from other parts of the world, good morning, good afternoon, or good evening, wherever you are. Thank you very much for joining. Appreciate if you could share and join the stream on next Saturday. And I will let you know if I could do a stream in between, but if not, we will meet again on Saturday. Thank you very much and bye bye. Bye for now.